Very good. Let's switch to English and let's start with an entirely new topic. As promised, after dealing more than one semester with web APIs and things like that, today we are going to switch into the world of user interfaces. You have done in other courses user interface related work, especially with Angular, and I think you also did a little bit of Java and WinForms and things like that, but not very deep dive, right? Okay, now today we are going to start with a technology which is called XAML. This will be a technology that is closely related to C# and is widely applicable to a large range of different user interface platforms. I have created a few slides for you. You can watch my screen. Let me share my screen now with the students in distance learning. Give me a sec. So students in distance learning should now see my screen. Is that correct?
Yeah, exactly.
Okay, very good. So we will talk about XAML, the Extensible Application Markup Language. What is this XAML? Let's quickly talk about that. It is a markup language. What is a markup language? We discussed that last time briefly. A markup language is essentially text with which you can describe a hierarchy of objects. You know XML, you know HTML, and now you know a third markup language. It is called XAML. XAML, in general, is a very generic language. You can store anything in XAML. You can store customers and orders. You can store cinema tickets. You can describe user interfaces. You can describe workflows. XAML is just like JSON, just like XML. You can describe anything with XAML. However, XAML was originally invented for describing user interfaces. So the sweet spot of XAML is describing user interfaces and designing user interfaces. XAML was originally invented in close relation to WPF, the Windows Presentation Foundation. The WPF, Windows Presentation Foundation, originally was a pure .NET framework thing. In the last years, a lot of things have changed. WPF nowadays is part of .NET Core, is open source, and it's a great piece of technology. But XAML in the last years went far beyond just WPF. It's not just WPF anymore. With XAML, you can build native Windows 10 store apps. They are called Universal Windows Platform Apps. Or even the newer API, which is called WinUI 3, it also uses XAML. But XAML is used way beyond just Windows apps. XAML is the basis of Xamarin Forms, and its predecessor, no, not predecessor, its Nachfolger, its successor, MAUI. We will hear about MAUI in the upcoming weeks in one of our guest lectures. XAML is used in many other contexts too. So what you learn today and probably next week with XAML is a technology that you can use for mobile apps on Android, on iOS. You can build Xbox games, you can build smart TV applications, you can, build Windows applications based on open source technology. So XAML is really a very important cornerstone of user interface development. It is closely related to Microsoft, that's true. So it's not that much used outside of the Microsoft ecosystem, but this is a C# and .NET course, so it is more than natural that we go a little bit into XAML. I asked you at the beginning of the semester whether you want to do a deep dive in this semester into XAML and WPF, or if you want to have a broader overview. And you decided you want to have a broader overview. So therefore, we will not just deal with XAML in this semester when it comes to user interfaces, but we will definitely look at other user interface technologies too. But XAML is especially important for you, not just because it's relevant in practice, but also because XAML and WPF will be part of your final exam next year, Matura, and therefore it's really important that you have good skills in XAML and you can really master it. If you look for jobs outside in the practice, you will find thousands and thousands of applications built on XAML. So this is also practically relevant, and it will make it easier for you to find jobs, maybe internships, or maybe real jobs after your matura. Good, this is XAML. Now what is the difference between HTML, the hypertext markup language, and XAML? The hypertext markup language was originally designed and invented for describing documents. So if you want to describe a document, you have headers, you have paragraphs. If you have a scientific paper, you maybe have some tables with measurements. You have images with maybe charts or things like that. You have sections, you have side topics, things like that. Does that ring a bell to you? That sounds like HTML, right? And this is what HTML was originally designed for, describing hypertext. Text documents which have links between each other. Now nowadays we use HTML to not just write text, but we build applications with that, correct? But you know from your own experience how hard it can be to build a professionally looking application in HTML. Because HTML was never designed to do it. Things like pull-down menus. It doesn't feel natural when it comes to HTML. Originally, a hypertext document doesn't have a pull-down menu, or a ribbon menu, or some fancy overlay dialogues with half-transparent backgrounds and animations. That was never the original idea of HTML. It is a great piece of engineering in HTML that it is possible to do that today. Greatly because to a technology which is called CSS. You know CSS. Yeah? But still, it feels a little bit forced into the technology. XAML is different. XAML is an application markup language. So the whole idea of XAML was not to describe just text documents with links in it. But XAML was invented to build applications, user interfaces for applications. And this is the sweet spot of XAML. This is what XAML can do really, really well. If you ask me, XAML has one big weakness. It has a lot of weakness, like every technology, but one especially big, and that's styling and templating. I personally think that a large part of the success of the web is not due to HTML, but it is due to CSS. CSS is awesome. CSS is incredibly powerful, and it's really mind-blowing what you can do with CSS and what modern rendering engines in browsers can do with CSS and how fast they can draw this stuff and so on. That's really, really powerful. XAML has styling and templating too. But in my opinion, and that's just my opinion, other people might have different opinions. In my opinion, the styling and templating mechanism of XAML is really powerful, but it does by far not reach to what CSS can do. So my dream would be XAML plus CSS. There have been projects, open source projects, which tried that, but they never really went big. So yeah, it is what it is. Okay. Now, how does XAML work? If you want, you can immediately follow along because, you know me, we'll not spend a lot of time in slides. We will immediately jump into Visual Studio and play a little bit with the XAML. Let's take a look at it, okay? I updated my Visual Studio today in the morning, so it might take a few seconds longer than usual to spin up my Visual Studio. There is a new version, by the way. I will create a new project, and we could now go for a WinUI project, for a UWP, Windows Universal Windows Platform application, which is just capable of running on Windows 10. We could create a MAUI application, we could create an UNO application and things like that, but I will not do that. For learning XAML, the simplest platform is WPF. So we will just take a look at WPF. I will show you some WPF tricks because our main focus today is about learning XAML. Not so much about learning some fancy frameworks and Windows 10 apps and Android apps and so on. Okay, let me take over the screen again. And now we are here in Visual Studio, create new project wizard. And if you want to follow along, look for WPF, Windows Presentation Foundation. And we want to build a WPF app, but don't take the WPF.NET framework. We don't want to do that. We want to look for WPF.NET Core. This looks good, you see? Oh, I haven't started my swimming tool yet. Let me show you that one. This is what we want to have, WPF or .NET Core. We want to use the greatest and latest technology in this course, not the old stuff. So we will use the open source version of .NET Core and use WPF in there. Believe it or not, when I was younger and started with WPF, people were asking Microsoft if they couldn't open source WPF. And Microsoft said, no way. This will never happen. Never ever. Hell would freeze before we can open source WPF because it's so complicated, so large, we cannot give it away. And guess what? Hell has frozen. WPF is open source today. So, great thing. Good. Take any folder, doesn't matter. Hello XAML, something like this. Use .NET 5, please use .NET 5. And then have a second patience. Could everybody create a XAML app in Visual Studio or Writer? Good? Anybody needs more time? Ready? Go. Okay, first thing. This nice little visual designer, forget about it in this course. We will not use any graphical designer for drawing and shifting around some boxes or things like that. Forget it. That's equally bad than writing go-tos in your C# code. No, you're not allowed to do that. Why? Because I want you to really understand how XAML works. Okay? Of course, everybody can drag around some input boxes, but the result is, as all generated code with UI technologies, is okay for prototypes. But for gaining a deeper understanding, you should take a look at the code and not at graphical designers. So, get rid of this graphical designer like that, and this is what we want to focus on. We want to focus on XAML and dive into what's going on here. Now let's take a look at what this XAML really is. As you can see here in the left up corner, we have something which is called a window. And down here, we have something which is called a grid. And here in the middle, we have some XML NS. And this is the first thing that I would like to discuss together with you. What's that window? What is that XML NS? And what does it have to do with WPF, XAML, and things like that? Now, the fundamental principle of XAML is that every element, XML element, is in the background a C# class. That sounds really obvious or kind of, okay, element is class, but it is a huge fundamental principle of XAML. Let's quickly go back a few years where you have learned how XML works. You know XML, right? You have used XML in many courses, right? How do you verify XML? How can you define what is possible in an XML file? There is a standard for that. How is it called? Any idea? Come on. It starts with X. Is it XSLT? No. XSD. Have you ever heard of XSD? XML Schema Definition Language. With XSD, you can define what is possible in an XML file. You can say, this XML file contains orders. Every order has, I don't know, a customer. An order has multiple order details. An order details record has a product, for instance. This is what you can define in XSD. If you work professionally with XML, you will sit down and write XSD. Similar to JSON. JSON is very generic, right? How can you define, limit what is possible in a JSON file? There is a standard for that. Do you know one? JSON schema. Do you see the template here? XML schema definition language, XSD. JSON schema. Schema is the name here. Schema means metadata. Like a database schema. You have done that in databases, right? You did create table, alter table, things like that. You're creating a schema. You say which tables do I have, which columns does the table have, and so on. That is a schema. And now back to XAML. What is the schema of XAML? Not XSD, not JSON schema, but the class library of C#. Correct, that's the point. That's the whole idea of XAML. The engineers of Microsoft sat down and said, why should we write an XML schema to say what's possible in a UI definition language when we already have a class hierarchy? Let's just use the class hierarchy. The fact that we can write grid here comes from the fact, if I press F1 for help, come on. Okay, it doesn't work here, so I have to go here and say WPF grid class. This is what I wanted to show you here. The fact that we can write here grid comes from the fact that there is a grid class here. See that one? And if we want to know what we can write for the properties here, what is possible here as the properties, see that one? We simply take a look here on the right hand side, take a look at the properties, and if we scroll down, we see all the properties of the grid class. And that is exactly what becomes attributes in XAML. Understand what I mean? So you are perfectly right with what you said. C# and .NET are the schema for XAML. If you understand that one, you understood already a lot. And that means XAML can be used with any C# or .NET library, but for us it's important that this is WPF in this case. Now, here it says just grid. But if you take a look at the definition of the class, then you will see that this is somewhere in a C# namespace. How does the C# namespace become available inside of our XAML file? And this, gentlemen, comes from that XML/NS up here. So these XML/NS, there is a mapping inside of XAML where XAML knows, okay, if I have this XML namespace, I'm in WPF world. There might be a different XML namespace if you, for instance, use a third-party control library with a great data grid or a fancy date picker, which is not built into WPF. Then you will need to add additional XML namespaces, and they will map to .NET namespaces. For you, to keep it simple, just add these 4 in WPF and you're fine. With other platforms, they might look different. Okay? Got it? Awesome. Good. These two, we will discuss them later on. Now, let's go up here and discuss the first line here. The first line says window x class hello XML hello XAML dot main window. Now, if you take a look here at the C# code, if you take a look here on the right hand side, you can see the XAML file, and below the XAML file you see the CS file. If you take a look into the C# file, you will see that our window is called main window and is derived from window. Do you see the similarity here? Window is a C# class. Here we have window. This class says main window, and guess what? This class is called main window. This is the link between C# and XAML. Got it? Please note that this class is partial. Do you see that one? Does anybody know what partial means? Yes?
You can have a second file that's also has classes.
Correct. Partial means that you can split the implementation of the class in different files. If the class becomes pretty large, you can split it up into multiple files. That is why this class is partial. That is very typical for UI platforms in C#. Blazor does it exactly the same way. Partial classes. Awesome. So this is a window. Is a window similar to an HTML document? You've worked with HTML before. The root of HTML is the document. And inside of the document you have the body. And inside of the body you have lots and lots and lots of HTML tags. So what is the analogy of window in HTML? Is it the HTML file? Is it the document? Or the body? Or what could it be? The analogy is really the document. It is not the body, because the body can contain lots and lots and lots of different HTML tags. But a window can only contain one and exactly one child. So this grid here is kind of like the body in HTML, okay? The window is kind of like the document, and the grid is kind of body. A grid can have multiple children. Got it? Good? Awesome. Awesome, awesome. Now, let's change the XAML a little bit, but before we do that, I would ask you to run the program. So please run the program, press the debug button. Please run it in the debugger. After a few moments, the app should come up. Here we have it. And what I'm going to do, I will take my Visual Studio and put it here on the left-hand side. For those students at home, if you have multiple monitors, you definitely have an advantage here. Because what I would like to have here is on the left-hand side Visual Studio, and on the right-hand side my WPF app. And guess what? See that one? Hot reloading. That means you can run your app just like you run a web app, for instance, and you can start tinkering around with your XAML file. Please do the following. Please delete the grid here and write button, click me. Save your file, and guess what? Here on the right hand side you now see a huge button that fills the entire screen, the entire app. Try that. So hot reloading is a feature which is present for quite a while in WPF, and Microsoft recently announced that their goal is to add hot reloading to all UI technologies that they have, including MAUI, Xamarin Forms. MAUI will become Xamarin Forms, Blazor and things like that. Blazor will have hot reloading in .NET 6. Does it work? Nice, doesn't it? Isn't it? But now we see the first differences. If you would add a button to an HTML file, would it be filling the entire screen? Absolutely not. Why? Well, because HTML is for defining text, and in a text you typically have a flow of paragraphs. Understand what I mean? But an app, think of a typical app like Word or Excel or I don't know, Deezer or Spotify or whatever you think of. They typically fill the entire window, and on the top they have a docking area where they have a ribbon or a pull-down menu. Maybe they have a footer which is docked to the bottom of the screen where they show some copyright information or the current playing music item or whatever. So the whole idea of an app is different than HTML, and therefore WPF, like all the other application frameworks based on XAML, they typically fill the entire screen, but you can change that, and I will show you how. Let's change XAML again. By the way, button, here, this button is of course, again, you don't need to look that up on your own. If you look for button here, then you will find System Windows Controls button, see that one? And this is exactly the class which will come out from this button. Got it? So if I here type, for instance, background red, something like this, and if I save that one, you will see that we now have a red button. Isn't that beautiful? And if I look here in the properties and scroll down a little bit, then we will see that we have a background property, and this background property is of type brush, see that one? And red is a typical brush. Got it? Good. Now let's make it more fancy, okay? Delete the button again, and this time we are going to use a stack panel. Oops. Stack panel. Please use a margin property here, and inside we do a button. This button should have a background which is green, and it should have a foreground which is, what did I come up with, yellow, and it should have a minimum height of 75. Just some samples, okay? I will make it so you can really follow along easily. This is the button. Inside of the button we have click me again. And then we will also do a text block which says text hello world, and there we change the font size to 75, something like this. Let's take 65, something like this. I will wait for a second until you could follow along. For those of you who already typed it in, by the way, these samples are linked in my slides, so you don't have to remember that, but it is a good idea to try it and to follow along typing in the code. Now, let's zoom in a little bit and talk about the code. What do you think the stack panel do? Stack panel.
It stacks everything.
Exactly, it stacks everything on top of each other, but it stacks it from top to bottom. So the first one is on top, the second one is below, below, below. You get the idea. So a very important difference here is that a stack panel doesn't have a single child, but has multiple children. Important here. Got it? A panel in general is a control which is not visible. A panel is only responsible for laying out other controls. So one important thing here, you have to remember that, and it will be important for your exam. I will not accept absolute positioning of controls. I want you to use panels. Why is this important? Because panels align automatically if you change the size of the screen. So if I take my window and I make it larger, you see the button becomes wider. And if I make it smaller again, it becomes smaller. If you position the button manually and define a fixed width of the button will not change its size, and I don't like that. So for exams, you have to use panels, okay? Important things. Now, I think you get background, you get foreground, you get a minimum height, you understand text, and you understand a font size. Any questions to that? Probably not, right? Good. Another trick before we go into a short break here. Up here, you have a nice little picker here. It says go to Live Visual Tree. If I click on that one, and I hover over the button and I click on the button, then you will see here on the left hand side, at least in Visual Studio, I'm not sure how this works in Rider, but in Visual Studio I get a Live Visual Tree. See that one? It's like the visual tree in the debug window in a browser. You know that F12 and you know the Chrome developer tools and so on. And here I can go to the button, see? I click on the button, I can show the properties, here are the properties, and I can, if I want live here, change the properties to see what's going on behind the scenes. Got it? So you see, modern C# feels a lot like web programming. It has live reloading, it has a visual tree window, you can manipulate with it, it supports a lot of things, and it supports panels, and panels are a great thing. Stack panel is just the first one. And if you are brave, try the following. Simply change stack panel orientation to horizontal and watch what's going on. Now suddenly, here, our WPF app doesn't stack the elements from top to bottom, but it stacks it from left to right, and it now fills the entire height, no longer the width. Funny, right? And of course you can't do that. You can do that nested. So what I can do, I can take the entire stack panel, check that one out, take the stack panel and put the stack panel inside of the stack panel, and here change the orientation back to vertical. And if you take a look what's going on now, it looks really strange because now we have stacking first horizontal, but here we have a nested stack panel which stacks vertical. See that one? Nice, isn't it? And everything else is calculated automatically. You see, it aligns nicely. And maybe now you get an idea what the difference is between XAML and HTML. Because tricks like that came in HTML only recently. Now, if you take a look at CSS and Flexbox and things like that, you can do all this crazy stuff, but not in HTML. You have to use CSS, and you have to use rather modern CSS to achieve things which are at least similar to what you see here. Okay? So, what should you remember from this first hour of XAML? XAML is an extensible markup language optimized for applications, not for documents, first. Second, the schema of XAML is the .NET library. So an element in XAML is a class in C#. We have panels which align controls or arrange controls. Arrange is the better word here. Yeah, and finally, yeah, you have the hot reloading features, so it feels a little bit like web development if you use it in modern Visual Studio and modern WPF. Okay? Good. Now we will do a short break, and after the break, we will dive deeper into XAML, and we will take a closer look at how this relates to classes, and if we could do the same thing in C#. Okay? Good.